Welcome to this video tutorial. Topic is dynamic RAM. Dynamic memory cells store data within a small capacitors. The advantage of this type of cell is that it is very simple, just allowing very large memory arrays to be constructed on a chip at a lower cost per bit. Main disadvantage is that it requires refreshing circuit because data is stored, binary bit is stored on a capacitor. The capacitor has the property that it discharges. In order to retain that data, capacitor should be charged in a specific intervals in order to store that bit for a long time. Okay. That charging of this capacitor in a specific interval is known as refreshing. Figure shows a DRAM cell consists of a MOS transistor and a capacitor. Okay, this figure shows a dynamic RAM cell consists of a capacitor and a MOSFET. Here, binary bit is stored in this capacitor. It has a row line and a column line is also known as bit line. In order to enable this capacitor, this bit row line should be at high level. Basic operations of a DRAM cell is explained here. There are two figures, figure A and figure B. Figure A shows writing a 1 into the memory cell. Figure A shows writing a 1 bit 1 into the memory cell. A law on the read-write enables the tri-state input buffer and disables the output buffer. This is the read-write line. In order to write a binary bit into this cell, this line should be low. When this line is low, it enables this input buffer. It enables this input buffer. At the same time, it disables this output buffer. And in order to use this memory cell, in order to enable this memory cell, this row line should be at high level. When row line is high, this transistor is turned on. It works as a closed switch and connect bit line to the capacitor. When this transistor is on, what happens is that this bit line is connected to this capacitor. And in order to write a 1 into the memory cell, data input line DIN should be high. DIN is connected to the input buffer. This input buffer is enabled. Therefore, DIN is connected through this bit line through the input buffer. Here bit line is high and transistor is on with the help of high on the row line that connects this bit line into the capacitor, and the capacitor charges to the maximum voltage in such a way 1 is stored on this DRAM cell. In figure B shows writing a 0 into the memory cell. Here also read write input is low, that enables this input buffer, and here DIN input is low because we are writing a 0 into the cell. DIN is low. Low on the DIN is connected to the bit line with the help of input buffer, and a row line should be high that enables this transistor. This transistor is on. When the transistor is on, what happens is that this bit line is connected to capacitor, and here bit line is at a low, therefore capacitor voltage is 0. In such a way, a 0 is stored into this DRAM cell. Okay. Figure B explains writing a 0 into the memory cell. Continuation of basic operations of a memory cell. Here figure C shows a reading a 1 from memory cell. Reading a 1 from memory cell. In order to read a data from this memory cell, read write line. This read write line should be high. When this is high, this disables input buffer and enables output buffer. This is the input buffer. In order to enable this input buffer, this line should be low. Okay, here this line is high. Okay. This therefore input buffer is disabled and output buffer is enabled, because here is the operations reading. Therefore no need to connect input data into the bit line. Therefore input buffer is disabled and output buffer is enabled. This transistor should be enabled with the help of row line. Row line should be high in order to switch on this transistor. When this transistor is on, what happens is that data on this capacitor, that is 1, is connected to bit line. When this is 1, what happens is that bit line should be at high level, and this high voltage is passed on to D out line or connected to D out line with the help of output buffer. Or in another way, 1 on the capacitor is connected to D out line in the reading operation. In figure B explains refreshing a stored 1. How this DRAM cell is refreshed when data is stored on that cell is 1. In order to refresh a DRAM cell, should read write line should be at high level. When read write line is high level, input buffer is disabled and output buffer is enabled. This output buffer is enabled, and row line should be high and refresh input should be high. When row line is high, what happens is that this transistor is on and this capacitor is connected to bit line. Here binary bit is 1, that 1 or high voltage is connected to bit line. Therefore bit line voltage is at a high level. High on bit line is connected to the input of refresh buffer with the help of output buffer. Here output buffer is enabled, therefore this high on bit line is passed on to the input of this refresh buffer with the help of output buffer. When refresh input is high, refresh buffer is enabled in such a way this input of refresh buffer is connected to bit line or colon line. Therefore D out line, here D out line, output of D out line is connected to bit line, and in this way capacitors again charge. It's a refreshing operation. Thank you.